Have you ever wondered if you could travel back in time to witness the wonders of the past, or leap forward to see the future? Time travel, a concept that has captivated us through countless books, films, and TV shows, presents a tantalizing question. Can we truly step outside the relentless march of time? In our daily lives, we're accustomed to moving freely in 3 dimensions, up and down, left and right, and forward and backward. Yet, there's another dimension we're always moving through, but rarely think about: time. It's our constant companion, ticking away relentlessly, shaping our past, present, and future. But what if we could navigate through time just as we navigate through space? This is where the concept of time travel comes into play. Imagine, if you will, being able to rewind the clock to relive cherished memories, or fast forward to catch a glimpse of what's yet to come. But how can we possibly embark on such a journey? Is it even possible to traverse this 4th dimension? Time travel suggests the possibility of journeying through time in a manner analogous to our movements through space. But unlike our spatial movements, which we control, our temporal journey seems to be a one-way ticket. We're perpetually moving forward, 1 second at a time, without any chance of reversing or skipping ahead. Yet, the human spirit is indomitable, and our curiosity insatiable. We've always pushed the boundaries of the possible, reaching for the stars and diving into the depths of the ocean. Why should time be any different? Indeed, some of the brightest minds have grappled with this question, exploring the feasibility of time travel. The idea of time travel often feels like the stuff of science fiction, an alluring concept that remains tantalizingly out of reach. But the question remains, is it just that, fiction? Or could it be that time travel is not just a figment of our collective imagination, but a genuine scientific possibility? So is it just science fiction, or could time travel be a reality? The idea of time travel isn't just a creation of imaginative minds, but it also has roots in serious scientific theories. To understand these roots, we need to delve into the world of Albert Einstein's theory of relativity. Now, don't be alarmed. We're going to break this down into bite-sized pieces. So, what is the theory of relativity? In a nutshell, it's a concept that space and time are interwoven into a single continuum known as space-time. What this means is that events occurring at the same time for one observer could occur at different times for another. A bit mind-boggling, isn't it? Now let's get to the juicy part. How does this relate to time travel? Well, Einstein's theory also suggests that space-time can be warped by gravity. Picture this: if you place a heavy object on a trampoline, the surface bends. That's essentially what happens to space-time around massive objects like planets and stars. This bending of space-time can potentially create shortcuts, known as wormholes. Imagine folding a piece of paper in half and then poking a hole through both layers. That hole is a wormhole, a tunnel between 2 points in space-time. In theory, if we could create or find one of these wormholes, we could use it to travel vast distances in space, or even through time itself. But there's a catch. While Einstein's equations allow for the existence of wormholes, they are highly unstable, collapsing the moment anything tries to pass through. Unless we find a way to keep them open, our dreams of time travel remain in the realm of science fiction. So, to sum it up, Einstein's theory of relativity provides a theoretical framework that allows for the possibility of time travel through the concept of wormholes. It's a complex idea, but one that has kept scientists and dreamers captivated for over a century. Time travel, according to Einstein's theory, isn't just a wild dream, but potentially achievable. The question is, can we overcome the practical challenges to make it a reality? Even though the theory allows it, could we, in practice, really build a time machine? That's the question that has both baffled and excited scientists and enthusiasts alike. Let's begin with the practical challenges of such an ambitious endeavor. One of the primary barriers to time travel is the energy requirements. Theoretical physicist Kip Thorne once proposed that a wormhole, a shortcut through space-time, could potentially be used for time travel. But to keep a wormhole stable, we would need a material with negative energy, also known as exotic matter. Unfortunately, we don't have any exotic matter just lying around. In fact, we're not even sure it exists. And let's say we do manage to find some, the amount we would need to keep a wormhole open is astronomical. Think of it as trying to keep a tunnel through a mountain open, but the mountain is constantly trying to collapse the tunnel. That's the kind of energy we're talking about. Then there's the danger of creating a wormhole itself. A wormhole is essentially a tear in the fabric of space-time. And just as a tear in a piece of fabric can lead to unraveling, a wormhole could potentially lead to catastrophic consequences. And we haven't even started on the paradoxes yet. Time travel paradoxes are the stuff of science fiction nightmares. The most famous one is perhaps the grandfather paradox. What happens if you travel back in time and accidentally prevent your grandparents from meeting? Would you cease to exist? And if you cease to exist, who traveled back in time in the first place? It's a mind-bending conundrum that has yet to be resolved. So the practicality of time travel is fraught with challenges. From energy requirements to potential dangers and paradoxes, it's a fascinating field, full of mystery and intrigue. But it's also one that requires a great deal of caution. While the theory is fascinating, the practicality of time travel remains a significant hurdle. Despite the challenges, researchers around the world are delving into the mysteries of time travel. The realm of time travel isn't just a playground for science fiction writers and movie directors, it's also a hotbed of rigorous scientific inquiry. Scientists, physicists, and researchers are relentlessly exploring the theoretical possibilities of time travel. One of the most intriguing lines of research involves particles. Scientists are looking at quantum particles and their peculiar behaviors to see if they might hold clues to time travel. For instance, there's a phenomenon in quantum physics called quantum superposition, where particles can exist in multiple states at once. Some researchers speculate that this could be a stepping stone to understanding how objects might exist in multiple times at once, which is a fundamental concept of time travel. Then there are the fascinating experiments with light, where scientists have been able to slow down and even stop light in its tracks. While this isn't time travel in the traditional sense, it does show how time can be manipulated in some way, which could potentially provide insights into how time travel might work. Parallel to these explorations are attempts to find evidence of natural wormholes. Wormholes are theoretical tunnels through the fabric of space-time that could potentially allow for time travel. The existence of wormholes is predicted by Einstein's theory of general relativity, but so far, we've yet to find concrete evidence of their existence. Scientists are using complex mathematical models and cutting-edge technology to search for signs of these elusive space-time shortcuts. The research into time travel is complex, mind-bending, and fraught with challenges. But it's these very challenges that make the pursuit so exhilarating for scientists. Every experiment, every theory, and every piece of research brings us one step closer to understanding the mysteries of time. The quest to unravel the secrets of time continues, driving scientists to push the boundaries of our understanding. The journey may be long and fraught with obstacles, but the potential rewards are astronomical. As we delve deeper into the mysteries of time travel, who knows what incredible discoveries await us? So, where do we stand on time travel? Is it a possibility or just a science fiction dream? Let's take a moment to gather our thoughts and recap what we've delved into so far. Time travel, in its essence, is a concept that has fascinated humans for centuries. From the early philosophical debates to the modern scientific explorations, it has remained a persistent fixture in our collective imagination. The theoretical framework of time travel, as we've seen, is rooted in the intricacies of Einstein's theory of relativity. According to this groundbreaking theory, time is not a constant entity. It can be warped and bent by gravity, leading to the tantalizing possibility of time travel. However, as we've also discussed, while time travel is theoretically possible, it poses some significant practical challenges. For one, the energy required to bend space-time to such an extent is beyond our current capabilities. Then there's the problem of paradoxes, such as the infamous grandfather paradox, which could potentially disrupt the very fabric of reality. Despite these hurdles, research into time travel is ongoing and fervent. Scientists around the world are probing the mysteries of space-time, exploring the potential of wormholes, and investigating the strange world of quantum mechanics. These studies are not just about time travel per se, but about understanding the fundamental nature of the universe itself. In conclusion, the verdict from science is clear yet complex. Time travel, in theory, is possible. The laws of physics, as we currently understand them, do not outright forbid it. However, making time travel a reality is a monumental challenge that requires leaps in scientific and technological advancements. It's a grand quest that pushes us to the very limits of our knowledge and understanding. Time travel, in theory, is possible, but whether we'll ever be able to achieve it remains one of the greatest mysteries